Okay. Uh, more than one constraint değil. More than one constraint. Yani mesela şöyle bir şey. Ee, problem şu olsun. Extremize f, let's say x, y, z, subject to two conditions like uh, g, x, y, z equals c1 and h, x, y, z c2. In this case, uh, the Lagrange function has two Lagrange multipliers. So it's something like this. L, X, Y, Z. Her bir constraint için bir tane multiplier gelecek. So lambda and another constraint for H, and it will be the following. So f, x, y, z plus, if I had only one constraint, then I would have lambda times g, x, y, z minus c1, let's say, plus, but if I have another, then I have mu times h, x, y, z minus c2. Okay? So the rest is the same. I mean, you do the same thing, but this time then look for critical points of L, X, Y, Z, lambda, mu. So we have 5 variables, okay? Let me just explain this on an example. I will not talk about the proof of this. Proof is similar to what I have done last week for 2 variables, okay? It's nothing different than that. It is a little bit more complicated, but the idea is the same, okay? Let's do this example. Find the maximum and minimum values of this function f, x, y, z equals x times y plus 2z. On the circle, that is the intersection of the plane x plus y plus z equals 0 and the sphere uh, x squared plus y squared plus z squared is equal to 24. Yani şunu yapmak istiyoruz. Elimizde bir tane küre var. So we have a sphere and we cut this sphere with a plane. Okay. So when we cut this sphere with a plane, you get a circle like this. Okay. Suppose this is the plane. And this is the intersection circle. Okay, let's call this circle C. And we would like to find the maximum and minimum values of which function? Of fxyz, which is x times y plus 2z on this circle. So there will be points like this. One of them will be here. Let's say one of them will be here. Okay. Atıyorum yani. So how do we find these points? Well, we write the Lagrangian function. Lagrange function. L x y z lambda and mu. By the way, so let me write here the functions. F x y z is what? Neydi bu? X times y plus 2z. G x y z is x plus y plus z equals 0. This is the first condition subject to. And the second one, x, y, z, this is the sphere, x squared plus y squared plus z squared minus 4 equals 0. So f is this, g is this function, and h is this. Right, x, y, z should satisfy both conditions. This one and this one. This gives a sphere, this gives a plane, and the intersection, of course, is a circle. Okay. So what is our L? This is F plus lambda times G and mu times H. Namely, it is xy plus 2z plus lambda times x plus y plus z plus mu times x squared plus y squared plus z squared minus 4. Okay, now we look for critical points as usual. Critical points. We write down the equations. Lx, derivative with respect to x is just y plus, right, derivative of this with respect to x is just y. And then from this we get lambda, and then we get 2x or 2 mu x. This is Lx. What about Ly? Ly is x plus lambda plus 2 mu y. Lz 2 plus lambda plus 2 mu z. L lambda is just x plus y plus z. L mu is just x squared plus y squared plus z squared minus 4. And you equate all these into 0 to find the critical values. All right. Ha, evet. 24 olacaktı bu. Özür dilerim. Değil mi? Evet, bunu yanlış yazmışım da ondan. 24. Bakayım. Evet, 24. Özür dilerim. So, 24. Peki. I have 5 equations and 5 unknowns. All right. How can we solve these? Let me see. Okay, now from this two, if I subtract one equation from the other one, you see I have only x and y here in both of them. So we get y minus x. Lambdas are gone, and then I have plus 2 2 times mu, and here x minus y equals 0. And from this we get x minus y, 2 mu minus 1 equals 0. Right? So from these two equations we get this gadget. This is equal to 0 gives me two possibilities. Possibility 1, x equals y, or 2 mu is equal to 1 over 2. Okay, let's look at the first case, case 2. First consider the second case, mu equals 1 over 2. If mu is 1 over 2, then we have what? İkinci denklem ne olacak? X artı y artı lambda eşittir 0. Bu ne olacak? 2 artı lambda artı z eşittir 0. Evet. Buradan da lambdaları eşitlersek, yani x artı y eşittir eksi lambda. Buradan da 2 artı z eşittir eksi lambda. Buradan da ne çıkar? X artı y 2 plus z. Okay. D. We have also this equation, x plus y plus z equals 0. We have also x plus y plus z equals 0, right? This equation. And if you combine these two, x artı, so instead of x plus y, I write 2 plus z. So we get 2 plus z. For this x plus y, I write 2 plus z plus another z equals 0. So 2 plus 2z equals 0. And from this we get z equals minus 1. If z is minus 1, then x plus y is equal to 1. Okay. And what else? All right. If x plus y is equal to 1, yes. Let's use the last equation also. Z is minus 1, right? Z is minus 1. If I write it here, I will get 1. So from the last equation, we get x squared plus y squared is equal to, z is minus 1, so z squared is plus 1. This is 1 minus 24 minus 23. So we have this. So I have these equations. X plus y equals 1 and x squared plus y squared is equal to 23. Alright, so let y equals 1 minus x from this and plug it into the equation. So we get x squared plus 1 minus x squared is 23. Buradan da ne çıkar? 2x kare eksi 2x eksi 22. Değil mi? Ya da x kare minus x minus 11. Buradan da ne çıkar? X is, bakayım buradan ne çıkıyormuş. Evet, çok hoş şeyler değil. Neyse, yazalım. 1 artı eksi b kare 1 eksi 4 ac 44 45. B kare 1 eksi 4 ac 44 45 bölü 2. Bu da 9 çarpı 5, yani 1 artı eksi 3 kök 5 bölü 2. So x is this. What about y? Y is 1 minus x. 1 çıkartırsak bundan 1. Şimdi bu artı eksi ise çıkarttığım zaman eksi artı olacak. Evet. Yani şöyle noktaları elde edeceğim. Özür dilerim. X 1 artı 3 kök 5 bölü 2. X buysa y 1 eksi 3 kök 5 bölü 2. Z neydi? Z was minus 1, right? Z was minus 1. Minus 1. Or 1 eksi 3 kök 5 bölü 2. Bu eksi ise bu sefer y artı olacak. Minus 1. So we got 2 points from this. Bu hangi durumdu? This was the case lambda equals 1 over 2. And we had another case. Either lambda was not lambda. Mu is 1 over 2. Or we had x equals y. Let's also consider the case 2. Case 1. X equals y. If x equals y, what we have? I already used these two equations. This equation has no xy in it. I have this. X equals y gives me 2x plus z equals 0. 2x plus z equals 0. 2x plus z equals 0. And I have the last equation, which is x squared y squared z squared is equal to 24. X equals y gives me 2x squared plus z squared is 24. So, okay. 2x squared plus z squared is equal to 24. And you just take one of them. So here z is minus 2x, and this gives me what? 2x squared plus z squared is 4x squared, and all adds up to 24. From this we get x squared is 4. So x is plus minus 2. If x is plus minus 2, then y is x, so it's also plus minus 2. What about z? And z is minus plus 4. Değil mi? I multiply by 2. So we get 2 points. 2, 2 minus 4 and minus 2 plus 4. So in total we have 4 points. Let me just use a color, different color, like these 2 points and these 2 points. And we just need to compute our function at these 4 points to decide whether f has a maximum or minimum at these points. So f, x, y, z was, let me check. what was this function? Xy plus 2z. So f of 2 minus 4. Nedir bu? 4 eksi 8 eksi 4. F minus 2 minus 2 4. Bu da nedir? 4 artı 8 daha 12. Okay. F of which point? So okay. 1 plus 3 root 5 over 2, 1 minus 3 root 5 over 2, and minus 1, right? This point. And I'll also do this one. So let's see what these are. Neydi bu? X times y. So I multiply this 2. This is 1 minus bunun karesi değil mi? Bu a artı b, bu a eksi b. Dolayısıyla bu a kare eksi b kare, yani 9 çarpı 5 yani 45. 45 değil mi? Bunun karesi eksi bunun karesi bölü 4 artı 2 çarpı eksi 1. Nedir bu? Eksi 44. 4'e böldük. Eksi 11. Eksi 2 daha eksi 13. Okay. What about this one? 1 minus this. 1 plus this. Minus 1. Well, this is the same thing. Again, minus 13. So, minimal value is this, right? And it is obtained at these 2 points, this one and this one. And maximal value is 12, and it is obtained at this point. So this is the maximum value, and this is the maximum point, and these are the minimal values. Minimum. Tamam mı? Bakayım doğru mu yapmışız? Evet. Doğru gözüküyor. Okay. I have only 4 minutes left. I have done all kinds of examples, actually. You may see in this context. There are several more solved examples and lots of exercises. Just work 3, 4, on 3, 4, 3, 5 exercises, then you will get ready. Of course, there is no guarantee that in the exam, you will find the easy way or the best way to solve these equations. There's always a factor of chance. If you start with the wrong equation, you may end up with nothing, but you just need to work so that you get used to computations, okay? To avoid sign errors or arithmetic errors. So you should just need to do exercises. All right, let me stop.